This is OR Rehab Lecture 8, Part 2. We resume at slide 11 in the slide set. In considering amplification, we can talk about different amplification systems that would require our attention. And these would include personal hearing aids, which we'll just abbreviate as PHA, assistive listening devices, group amplification systems, or you might otherwise think of them as classroom amplification systems, and cochlear implants and other implantable hearing devices. Technically, under the law, cochlear implant is not a hearing aid, it's a hearing device. Cochlear implant is a surgically partially implantable device which interfaces with a sort of a computer that's worn either at the ear, at ear level, which provides stimulation of the auditory nerve. In the rest of this rest of Lecture 8, and primarily in Lecture 9, we'll consider really more assistive listening devices. In Lecture 10, we'll kind of consider assistive listening devices and group amplification systems. And later in the course, in the pediatric section, we'll, and I'm not sure where that'll be, Lecture 14, 15, I don't know where it'll be. We'll deal with cochlear implants. While cochlear implants are not necessarily a pediatric issue, they have their most robust application for persons, for children who are very young. So we will certainly consider them at some point. But in this context, we're going to deal really more with the personal hearing aids and these other kinds of devices, which tend to be a little bit more adult-oriented. So despite those sort of functional differences or functional different systems that I just presented to you at slide 11, what we have to kind of consider is that all these amplification systems with some minor changes have some basic components in common. All of these amplification systems are going to have some kind of input transducer. So when we think about what the most common input transducer we will deal with is a microphone. Transducer, I'm sure you learned in your hearing science class, is some device that changes energy from one form into another. So a microphone is a very classic example of a device that converts sound wave, acoustic energy, into an electrical signal. At that point, it's delivered to some kind of amplification system, and a couple things might happen to that electrical signal at that point. But fundamentally, we have an acoustic to electrical conversion. Another aspect of all amplification systems will be some kind of amplifier or processor, something that acts on that input signal. So the input signal has to be transformed in some way. It has to be have energy added to it. It has to possibly have some selective properties or selective amplification applied to it, meaning some frequencies will be amplified more than other frequencies. The guidance for what frequencies need to get more amplification than others is going to come from none other than our old friend the audiogram. So the point being that we'll have to restore as appropriate the energy as a function of frequency. Hearing aids will also have some kind of output transducer. So the output transducer, again, is something that's going to convert energy typically from an electrical signal out back into acoustic energy. So these as loudspeakers, as a loudspeaker might be in your car, in your telephones, and just speakers that might be part of a stereo or music reproduction system. In hearing aids, oddly enough, the output transducer, the device that turns electrical energy into acoustic energy, has this what now seems to be this odd name of receiver. And it seems like an odd name to me too, but this has been the name for this particular component since the 1930s thereabouts. So it's very hard to get the industry to kind of change over the nomenclature of the parts. In most cases, but not exclusively, the output transducer is going to be a device that changes energy into an acoustic signal, and that would be then this speaker kind of thing. Now, there are other alternatives for output transduction. If it's turning it into sound waves, then it's creating an air-conducted signal. It's also possible that we'll see that the output might be vibration, which would now go to some kind of bone conduction device. So technically speaking, there are air conduction types of hearing aids and bone conduction types of hearing aids. And when we think about what a cochlear implant does, it really doesn't kind of align with this at all, because it converts energy into electrical pulses. Those electrical pulses then are electrical pulses delivered to the ends of the auditory nerve. So cochlear implants doesn't exactly follow this model exactly. In principle, though, most of these, cochlear implants still has to have a microphone, still has a processor, but the output is not either air conduction nor bone conduction. All of these devices have to have a power source. You could think of that as being a battery. Most of these devices also have some kind of control. And so an older concept of a control would have been a volume control. It might have some kind of switch that enables this thing to be turned on or off, and or to switch across different options of performance. In this next schematic here, this schematic illustrates sort of a generalized sort of hearing aid. And in this conceptualization, here's the sound wave out in the world as an acoustic signal. The microphone intercepts that acoustic signal and basically converts it into an electrical signal. So there's an acoustic to electrical conversion. All of this is powered by a battery, as you see somewhere. And then that electrical version of the acoustic signal drops into an amplifier. Now, truth be told, in most contemporary hearing aids, this isn't an amplifier per se, as it is more a processor. And it would be sort of probably at this point here, there'd be an analog to digital conversion, an A to D converter. So in principle, this electrical signal then gets converted from electrical signal to a binary code. Then that goes to the processor, and then still, in principle, all of the things that happen to the signal happen at the amplifier stage. At the output of the amplifier, and if we were to think about it as an analog again, what you see is now we see a bigger signal, and that would sort of be symbolic of there is now energy's been added to the input electrical signal. Now it's a bigger electrical signal. In digital processors, there'd be a D to A converter here to convert from the digital code back into an analog code. Eventually, then that analog electrical signal then would then be sent to the receiver, and the receiver now converts the electrical signal into acoustic energy. And now you have again a sound wave out in the air, and that's delivered then into the person's ear canal, typically. Here's a fuzzy cutaway of a hearing aid. Now in the next slide, there's a legend that kind of keys all of these different parts. This particular style of hearing aid is called a behind-the-ear type of hearing aid. This particular hearing aid requires another part that's not on here that would come off of here, which would be tubing, and that tubing then would go to a piece that might sit in the ear so that you've got an output into the ear canal. But right here, this doesn't have that. This just simply has the hearing aid just sort of by itself. Let's identify some of the parts, not necessarily in the order that they have A, B, C, but in the order that I did. Up here, number C is the microphone. So this is the microphone, and what this is doing, as you can see, this hangs over the ear. So the person's ear would be here, and so this is sitting on the top of the ear. So the microphone is facing front, is facing forward. So presumably, whoever the person is looking at, that's what the microphone, its pickup, is picking up. So the microphone picks up this signal in this hearing aid, sends it to the processor, which is in here. The processor now, here's a volume control or an adjustment. Down here at B is the battery. A over here is a switch, so this switch is up and down. Here's the battery source. Notice, by the way, relatively speaking, the battery is relatively the largest part of the hearing aid. And then, so signal comes in, goes to the processor, draws energy from here, and now sends the signal back out the receiver. And so this is the receiver, and then the sound goes out and then down and ultimately out into the person's ear. The other thing that I didn't identify here is this device here. This device built in is called a telcoil. And the telcoil, as you can see it when we look at it, is a wrapped copper around a magnet. And this job, what it does is this is an input transducer for electromagnetic energy. And electromagnetic energy can be used in some large room applications to provide the intended message to get to the listener. If you've looked at the HLAA stuff, they're talking about, I misspelled that, talking about the looping of America. And so with the loop, copper loop in a room generates electromagnetic energy, and then that would be picked up by this. So if a person's wearing a hearing aid and they know that a room is looped, they flip this switch to the T setting for telcoil, and now whatever's out in the person, the talker in the room is speaking through a system which is also generating an electromagnetic signal. This thing picks it up. So it's an advantage for the person to have this in their hearing aid, and you'll see that a number of recommendations sort of include that. Right now, as I said, this hearing aid without a coupler on here, the sound would end here, which would be useless to anybody. So the hearing aid itself, with its electronic parts, still needs a way to deliver the sound into the ear canal. And there's a legend for you to look at and make some more sense out of as you look at that. So again, if we look at a basic overview of the components of these of basic amplification systems, and specifically of hearing aids, we'll see that there's a couple of things that are important. Microphone, as I said, its job is to convert the energy from acoustic to electrical, and again, all hearing aids are going to have a microphone. Amplifier or digital processor is going to increase or amplify the signal. The basic idea is that you've got input coming in to the hearing aid as probably some speech sounds or something. So you've got some kind of input. The hearing aid amplifier or other amplification device is going to add energy to that. We can call the additional energy, we can call that gain. So we can say input plus gain is what is going to ultimately yield the output of the hearing aid. So we could measure this in specific electroacoustic test boxes, and we know what the input to the hearing aid is. So if I put a 60 decibel input into a hearing aid, and I measure the output, and the output is 90 decibels, then I know 90 minus 60, that means I had a gain of 30 decibels at that particular frequency, and so on. And those are all part of some standard quality control measures that would be employed on hearing aids. The components, again, of the hearing aid, microphone, the amplifier, the receiver, again, this would be the hearing aid's term for a loudspeaker, converts electrical signal to an acoustic signal, and then delivers that acoustic signal, the output, through some kind of tubing or through an ear mold, an earpiece that's specifically molded to the ear to provide comfortable and consistent delivery of the signal into the ear canal. Batteries, again, like any batteries that you might think about, the batteries there are there to provide a source of power, actually a voltage. So batteries, as in any sort of battery, is a little chemical can that has chemicals that has free electrons in them, and when you apply your poles to that, you can extract those free electrons. All right, so we'll continue on with a little bit more on components in part 3.